Dear students, welcome back to my another lesson. So in this lesson we will discuss about work, energy and power. So without wasting time, let us discuss the first term, work. So in the lower classes you might be studied about the work. Work can be defined as the product of force and the displacement. So let me write it. Work W is equal to force into displacement, and as you know, work is a scalar quantity. Now if I take work as a scalar quantity, then I will be writing the work done by a force. The force is a constant force. So let me write work done by a constant force. So work done by a constant force. So as I told you, work is a scalar quantity. So if I am writing that work W as a product of a force and the displacement, then displacement is a vector quantity and force is also a vector quantity. So scalar dot product of force and displacement will be called as the work. So as you know, A dot B is equal to AB cos theta. So I can write the work just like this: W is equal to F ds cos theta. That means here we have an angle. This angle is the angle between the force and the displacement. For example, let me consider a force as a vector. So this is my force vector F, which is acting on an object. And just imagine if the displacement is not in the same direction of the force. So I can represent the displacement like this. Suppose this is an imaginary displacement ds, and this is the actual direction of the application of the force. So here we have a theta, that is the angle between the direction of applied force and the displacement. So here we have an angular deviation between the applied force and the displacement. So I can write W is equal to F ds cos theta. So we will consider work in 2-3 cases. So let me write the first case. Case 1. So if theta is equal to 0, if theta equal to 0, what will happen? Work W is equal to F ds cos 0. That means cos 0 is equal to 1. So work will be F ds. That means we have a maximum work. So what does it mean? Its meaning is very simple. If you are considering a wooden box or any object and I am applying a force like this, this is my force. Now the direction of the displacement is in this way. So I have represented the direction of the displacement like this, and here you can see that the force and displacement are in the same direction. So there will be no angular deviation. So theta will be equal to 0. So force will be maximum. So remember, maximum force will be offered only when the displacement occurs in the direction of force. Now let us consider case 2, that is the angle theta is equal to 90 degree. Okay, let us see some examples. So in the first picture you can see a ball is rolling on a rod. So here the weight of the ball will be acting downward always, so which will be mg, but the displacement of the ball is just perpendicular to the weight. The weight is actually the force. So F is equal to weight, which is equal to mg. So the direction of the displacement will be just perpendicular to the force. So here also we have the work done, W is equal to F ds cos 90. So I can write it as W is equal to F ds into 0, because cos 90 is equal to 0. So W will be 0. So the work will be vanishing always when the displacement is perpendicular to the applied force. Similarly, in the second diagram, you might be observed that a man is walking on a road with a box on his head. So here the weight of the box will be acting downward, and he is walking horizontally. That means the displacement is just 90 degree with respect to the applied force. So here also work done will be 0. Now in the third case, it is very important, the circular motion. So in circular motion, here you can see that a thread is attached on a stone, and the stone is actually revolving. So there will be a centripetal force which will be acting always towards the center. So here the boy is actually whirling the stone. So during the motion of the stone, the applied force will be always towards the center, but the displacement is perpendicular to the applied force, because we know that the direction of velocity is perpendicular to the radius at any point of instant. So here also we can say that the centripetal force mv square by r will be always perpendicular to the velocity. So here also work done will be 0. Now let us consider case 3. In case 3, I am taking that theta is less than 90 degree. So less than 90 degree means, so here our normal example, that is we have to consider one wooden box or any block of weight. Here I am going to apply a force. This is the force, and the displacement will be of in the same direction or may make an angle theta. But remember, the angle must be less than 90 degrees. So I am just making a perpendicular here. So this will be 90 degree and this is 0 degree. So other than 0 and 90 degree, that means any angle which lies between 0 and 90 will have a work. As you know, work is equal to force into displacement, that is FDS cos. For example, if it is a 45 degree, what will be its values? So this will be always a positive value. Work is always greater than 0. So this condition is what we call as the positive work. So remember, work will be always positive whenever the angle is between 0 and 90 degree. Now let us consider case 4. So here you can see that a car is moving through an inclined road, will make an angle. For example, this is the horizontal and the road makes an angle theta with respect to the horizontal. So here the weight of the car will be always acting downward. This will be mg, and the frictional force must be acting just opposite to the force, and the car is moving just opposite to the applied frictional force. So applied frictional force means the force developed on the brake pads. So here we can see that the theta will be less than 180 degree or greater than 90 and less than 180. So in this case, what will happen? I am taking a general case, theta is equal to 180 degree. So here work done W is equal to F ds cos 180. So cos 180 will be minus. So here W will be a negative value. That means work done is negative. So in the case of acceleration and the displacement, or the displacement and the force which is in opposite direction, then the work will be always a negative value. The best example is the applying of brake when a car is moving on a inclined road or a level road.